I have a very small role here because I'm speaking before two people who have names on buildings at Hope. So I realize none of you really want to hear from me. Jim Bultman is coming up, and then our main event, Paul Schaap. So I'm here just to say welcome, and so I will say that welcome. Really glad to have all of you here. We've had a robust day so far with lots of folks coming back to Hope who haven't been here for a while, and some folks who are always here, and it's been a great milestone weekend so far. We talk about Hope College as being a place whose the purpose of this institution at the end of the day is to be a place that brings hope to the world. And that is by far my favorite thing about this institution. And what I love about it is that is not a new idea. That's what we've been up to for 162 years. This place has always existed to bring hope to the world. And what the founders of this place really believed is that the way we would bring hope to the world is not just through passion and zeal, but that we would bring hope to the world through education. And I love that we get to hear from Paul Schaap today, who has spent his whole life bringing hope to the world. And he spent his whole life bringing hope to the world as an academician. And Paul, it's not an exaggeration. We can quite literally say that you have brought light to the world through your work. So we are so proud. And thank you. We are so proud of you, proud to claim you as part of the Hope family. You have made this place better in so many ways. I think it's really cool, and there are probably not a lot of colleges who can say this, that Paul's very humble, but one of our most generous supporters, if you sort of look at all the people who supported Hope over the years, Paul is one of our most generous supporters, Paul and his wife Carol. And I think it's cool. I think it's cool that one of our most generous supporters is an academician. Someone who has an academician generously supporting a college. And that's cool. That makes sense. So I'm really glad to have all of you here. I'm really proud, Paul, of you and your work, and grateful for all you've done for Hope. What I'll do now is turn it over to the OG president, Dr. Jim Bultman. OG, do you know what OG stands for?
Old guard.
It does not stand for old guard. It stands for original gangster. And when I think of Jim Bultman, that's what I think of, gangster. Jim became president while I was here as a student, and is in my Hall of Fame. And to say that Hope is a better place because of your leadership, Jim, is a complete understatement. So it's an honor to turn it over to the OG president, Dr. Jim Bultman.
Well, I'm not all that smart, but I did think that the O would stand for old. And I was hoping that the G would stand for gent. But anyway, it's great to be here, and I am so pleased that I'm able to introduce Paul Schaap. Really a privilege to do so. Paul Schaap, yeah. Student, teacher, professor, researcher, entrepreneur, philanthropist. All of those words are fitting for you, Paul. I think of Paul as a student, and a little pun also in light of what Bultman said about luminescence, and that is that Paul was bright. He chose Hope for his undergraduate work, and he had some of the kind of legends of Hope chemistry to guide him, including Jean Jekyll, who is here today. Jean. I hesitate to tell this story about Jean, but I'm going to very quickly. When I was a freshman student, I was in Dr. Jekyll's chemistry class, and I was also playing football, and it came to the Thanksgiving break. I was so eager to get home for a little break. But we had this assignment of finding one of the unknowns in this in class. And all the other students had found their unknown, and they were gone. And I was alone in the lab. Dr. Jekyll was there, of course. And I had repeated this solution several times. I could find nothing. So I came to him and I said, Dr. Jekyll, I just can't find anything in this solution. He said, well, is that your answer? And I said, you're kidding me. It was distilled water. Well, anyway, it was quite a group of scientists here that I know influenced Paul's life in some marvelous ways. We think of course, of Kleinexel and Bazile, but I also think, and Paul does, of Jekyll and Brink, and then of Neckers and Doyle, and so many others, including the scientists that are here today that do so well in combining the academic work with the research and doing it with undergrad students. It's really quite amazing how this has been perpetuated through the years, and I want to thank all of you for that. But after Paul graduated from Hope, of course, being real bright, he went to Harvard. And there he graduated in 3 years with a degree in organic chemistry, and then took his first academic job at Wayne State University. And it would be fair to say that Paul is a legitimate legend at Wayne State University. The chemistry building is now named for him. And what he did there with graduate students and the work was just really incredible. And that institution is much, much stronger, as is Hope, because of A. Paul Schaap. A researcher, I can't even imagine how Paul, and quite frankly all the rest of you who do this so well, can combine such a strong academic emphasis along with an active research program. And Paul was able to do this very, very well. As you know, he became not only this legend on campus, but also the founder and president CEO of Lumigen Incorporated. This was, of course, a result of Paul's lifelong interest in how did the firefly emit such a bright light. And he worked with dioxetanes, and he discovered that there were chemicals that could produce this same light in the diagnostic and medical diagnostics. And Paul became very famous for this. I think it's fair to say that the luminescence is, I didn't say that word quite right, Paul, but I know what you did. Okay, I figured. Luminescence is what I was looking for. What he has discovered is used throughout the world in medical diagnostics. Really a tribute to you, Paul, for all the good that you have done there. And then just a word about philanthropy. I think it was one of the first meetings that I had when I became president of Hope, and Jim Gentile, who was then the dean for the natural and applied sciences, came to me and said, Jim, we need to build a new science building. And as scientists, we have come up with this tremendous facility. The only thing is we don't quite have the money for it yet. And should we go ahead with it? And I said, well, the science division, with due respect to all of the other divisions on campus, is really the plum of Hope and has been for a long time. And in order to retain that lofty position, Hope needed a new science facility and really a remodeling of Old Peel. And so I said, let's do it. And then, fortunately, Paul and Carol stepped up to give the lead gift for this exceptional facility. Well, I was desperate. And you know, what I think is impressive about their gift, so impressive really, is that Paul understood that it wasn't just the building that would do it. You had to have great scientists come here. And that resulted in some, what I call kind of startup money for getting the best people here at Hope in the sciences. And then it became, how do we develop these people and give them the resources they have to do the work that they're called to do. And then it wasn't just in the sciences, but I think Paul and Carol saw that they really wanted to give to students more broadly, even outside of the sciences. And so for 40 years, they've given scholarship money and financial aid to students who otherwise might not be able to afford to come here. And it was the development of both students and faculty, I think, that has endeared Paul Schaap to so many people. I think of just the numerous ways that they have thought of what it takes to develop the best student product. And in the end, they saw a need for a new student center, and so they contributed to that. And they also appreciated very much the spiritual aspect. And so it's called the Carol and Paul Schaap Chapel in Graves Hall. And giving to so many things at Hope, but also in their community, to Wayne State. It's just remarkable, Paul, how much you have been blessed, but also blessed to be a blessing to others. And we are deeply grateful for you. Just one last comment, and that is that the celebration of undergraduate research and creative activity is now named for Carol and Paul Schaap. I think that's so appropriate, and I think it's appropriate because it identifies not only the scholarship and research that is done in the sciences, but also what is done campus-wide. And then I'll just close with this remark, and that is that no one achieves at such a high level without the understanding and support of a caring spouse. And so the accolades that come your way today, Paul, as you well can appreciate, also go to Carol and the wonderful relationship that you have had with her all these years. And she passed away a year and a half ago. Still remember the service that you planned. It was beautiful. And we remember both of you with great affection. Thank you.
After that, I would just sit here. Thank you, Chief. I got to tell you a little story. Standing up in front of this wonderful group, Doug Neckers, who I worked with in undergraduate chemistry research. At the end of my time, at 3.5 years, I was about to go off to the University of Groningen for 6 months to do research there. So he asked me if I would give this was in the old science hall, a chalk talk on what my research had been. And so I'm standing up like I am now, and in the door walks our then current president, Dr. Calvin A. Vanderwerf. Now, Dr. Vanderwerf was an organic chemist by rights anyway. So he comes to the front row and sits down. You talk about being nervous. But anyway, I'm pleased to be here. I'm not going to give kind of a formal talk. I want to give you a little insight into how important Hope College was to me in getting me started in a career. But I'd be pleased if anyone has questions as we're talking about some of this, if you wanted to ask a question. So the focus is undergraduate research at Hope College. Okay, this starts us out now at Hope. I was a high school student at Penn High near Mishawaka, Indiana. And this is me as a senior in high school with Clyde Mott, my high school chemistry teacher, pointing to me how we could do a distillation. I thought it was research because this experiment was not in a book. In fact, it turned out it was taking fermented molasses and distilling it. Okay. We didn't do anything with the alcohol. But I just learned so much so inspired by Mr. Mott that I said, I've got to make chemistry my career. And so, you know, if you're growing up in Indiana and you want to be a scientist, you naturally think about Purdue University. Okay? And I'm kind of mentioning this to, it was Jim Slager, a Hope graduate, chemist at Miles Laboratory with North Church. Sorry. Oh, I'm sorry.
I got it recording. Can you find this through science?
Well, Michael, step back. Sorry. Yes. All right, so I asked Mr. Slater about a place where I could go to college and study chemistry. And he said, no, not Purdue. What are you talking about? And he said, you've got to go up to Hope College and talk to the faculty there. So I did. I came up here, talked to various of the faculty, and never looked back. Purdue, everything else was out of the picture at that point. Now, I knew about Hope. My dad was a graduate, but he went on to be a minister. He didn't even know about chemistry. So, anyway, I was directed here by a good friend who said, "This is, if you like chemistry, this is where you've got to go." So I came here, worked hard with my classes, and had a lot of help from students, from teaching assistants. Jim Sharon was one of them in particular.
I blame my father for everything he knows.
Okay, I'll let it go with that. So, but Jim and some of the other students helped me. I got through my initial classes, finished organic chemistry, and at that point, next slide. This is a picture from a couple of years later, but this shows who I'm sitting next to was my teaching assistant. You see where I'm seated there in the right-hand second row? And who's next to me? Second one up, that's me, that's Jim. Sitting right next to me. And these were my colleagues. The Chemistry Club is an affiliate of the American Chemical Society. I joined the ACS then as a student, and I'm still a member. You probably are too. So, lower. Well, what I was going to point to is the one E. Jekyll right there. You see him up there on the far right? And he's here right now.
He's a member still.
You're still a member of the ACS?
Oh, yeah.
Fantastic. So, I worked hard in my classes, I got good grades, and then one day, and the next one, Dr. Deckers comes to me and says, would you like to do research? I said, absolutely. So he invited me to join his research group, which I did, and he began teaching me about how to run instrumentation. Jim, of course, recognizes that as a gas chromatograph and analyzing the results of a reaction and getting the amount of materials, rock products that were formed. And I did a lot of that with Dr. Deckers. Got so involved that one evening, it was a Saturday evening, and I lived in town with my grandparents. Okay, so I stayed on. Everybody else had gone home. And I worked the night through. Not a very good, safe thing to do, I understand that. But that next morning, my grandparents came to find me. I was still in the laboratory doing the experiments. Next one, please. Now, not only do you need to do your experiments, you need to know the literature. You need to base your experiments on what others have done, what their understanding of a particular process is. And here's an illustration of Dr. Necker's and I having a discussion about the literature and understanding the basis for doing the research and preparing. Next slide. This, which was my first research publication. This was published in the Journal of Organic Chemistry. I was, it's hard to say, overwhelmed with how important this was to me, to see my name in the published literature. It had been sent out for peer review. Others had commented, accepted it, and it had been peer review publication. Dr. Neckers and I think, ended up having 3 publications together. And toward the end of my, and I mentioned it, and toward the end of my 3.5 years, my last semester, he arranged that I would go to the University of Groningen and spend 6 months working with Professor Winberg, which I did. I absolutely loved it. And in fact, in preparation for doing that, I learned to speak Dutch. And that was with a tape machine. So by myself, learning from the tape. And because I was going to get a grade for this, my final exam was sitting alone with a member of the board who was fluent in Dutch origin. I'm forgetting his name. But that was my training in the Dutch language. So I went over there, spent 6 months, 3 publications with Dr. Winberg and his colleagues, and absolutely loved it. But then as I'm thinking about graduate school, Dr. Neckers again helps me. He had postdoc at Harvard with P.D. Barton. And so, I'll call him Doug. Doug says to me, if you can get in, you've got to go work for P.D. Barton. Dr. Bartlett was a world-famous physical organic chemist. Jim certainly knows of him, who was famous for the physical organicity, study a reaction, learn its mechanism, find out how to apply that information. And so I did. I went to Harvard, worked for Dr. Neckers, Dr. Bartlett, worked hard. The same mentality that I learned here of working hard at what I loved followed me at Harvard. And in 3 years, I was ready to move on to find an academic position. I've got to tell you a side story. Dr. Bartlett would always have a year at his home for all the group to come with a campfire. We'd be sitting around. And one of my so-called friends says to Dr. Bartlett, how come Schaap's getting out in 3 years? And he turns to me and says, is that right? Well, by then it was too late because I had my academic job. And here again, Dr. Neckers stepped in. As I was getting ready to find an academic position, because I wanted to teach, but I also wanted to do research. And so he makes a call, unbeknownst to me, to a friend of his at Wayne State University, Carl Johnson. And he says, you ought to take a look at this guy. And so I was invited to go to Wayne State. I give an introductory lecture. which I guess went okay because they hired me. But at the excuse me, end of the lecture, Carl Johnson kind of whispers to me and says, "Paul, very nice. Is this stuff good for anything?" What I was describing during my lecture at Wayne State was the result of my Harvard work, which had been to find that the first way to make one of these, as Jim pointed out, one of these chemiluminescent molecules, a dioxetane. You're going to see its structure is a 4-member ring peroxide, has the energy of a firefly. But part of my research at Harvard was to find a way to make it in the laboratory. Now, it didn't give a whole lot of light. You'd have to go in a very dark room and warm it up a little bit, and you could see it glowing. I'll never forget, I did it late one night in the dark room at Harvard. The next morning, Dr. Bartlett was sitting at my lab bench down there, waiting for me to come in and show it to him. So, I took that project with me to Wayne State University. And my students, and postdocs, and myself then worked on that idea of a luminescent material for 15 years before we were able to put all the pieces together to make it. That's okay. That's okay. To make to make it stable, to be able to trigger it. Maybe it would be useful for something. We weren't sure. So this is a picture of me. And by the way, we had sort of our breakthrough moment in 1985 when one of my students was able to do what I'm demonstrating there. That was a day for dancing around the laboratory. And that observation led me to form the company, to file the papers in 1987 for Lumigen. Now, I don't know much about businesses. I've already been in academics. Although I will say, Jim will agree with me, running a research group where you're out searching for money, you're writing reports, you're writing grant proposals, you're managing people, that's a business, okay? It doesn't have all the things that go with the real business, but it comes close. And so I started the company, was able to attract my PhD students that had been working on this to join me in the company. And they did, and so we were able to move into our Lumigen laboratories, and that's, the picture here is the demonstration at the opening of our laboratories in Southfield, Michigan. That, in fact, if you look, you see the name down below there, and you see the oval with oxygen, oxygen, carbon, carbon. That 4-member ring, that's a dioxetane. That has the energy. That's what we as a chemist put in. Now it's got lots of pieces that make the molecule stable, make it what we call triggerable. And there are lots of ways to trigger this. When I pour it in there, it turns out it has one silyl group, and I'm adding fluoride ion. And those of you who do protecting chemistry, fluoride takes silyl groups off, and it creates an unstable fluoride and generates the luminescence spontaneously. Well, that's kind of a generic concept because the protecting group can be, for example, a phosphate group. And then you can have an enzyme remove the phosphate and trigger it. And Jim would tell you about fluorescent materials that are triggered, if you will, to become fluorescent with the enzyme alkaline phosphatase. So the reason for starting the company, moving into our own facility, is that various companies, life science, diagnostic companies, began to request samples and say, we'd like to test this in our instrumentation, both for DNA detection, because a lot of this was radioactive testing, for immunoassays. You draw a blood sample, you put it in a machine, like that kind of stuff. And that's just a very, very early machine. Now, we didn't make the machines. Those were our potential customers. What we made was the chemiluminescent material that allowed the machine to detect the various things that were injected into one compartment. So there would be separation, and you needed the detection, and that detection was done with the material. Much more sensitive than we've ever been able to do. Now, Lumigen still exists. It was sold a long time, it was quite a while ago, to our largest customer, Beckman Coulter, and they're in Chaska, Minnesota. They still use our material. They come to Lumigen in Southfield. It's got 45 employees. They weekly pick up huge carloads of this luminescent material, take it up to Chaska, repackage it, and something on the order of 2 billion tests a year are run through their instrumentation and our material. So that's sort of the story of luminescence and my involvement. Thank you.
Well, thank you very much. I'm John Peterson, Dean of Natural and Applied Sciences at Hope, and now I have the privilege of bringing a student panel up, and we are going to find out what the building has enabled in their science education. I think of a line by Winston Churchill. He said, we design our spaces, and then they design us. And it's true when you think about it. So please come on up, students. Have a seat. And if we can just start, tell us your name and what your major is.
I'm Shay. I just graduated. I was a biology major here, and I study under Dr. My name is Sophia Rosenberger. I study religion and biochemistry double major at Hope College, and I work in the lab of Dr. Leah Chase.
My name is Alexis Putt, and I also just graduated. I majored in neuroscience, and I work in Dr. Calvo Machoa's lab.
My name is Matthias O'Hara. I have a double major in neuroscience psychology, and I'm working under Dr. Andrew Gall.
Hi, I'm Ethan. I am majoring in biochemistry, and I work with Dr. Calvo.
Hi, my name is Miracle. I'm majoring in nursing currently, and I work with Dr. Erica Frost.
All right, Sophia. What's one discovery or lab experience that really deepened your passion for the field of biochemistry and molecular biology?
Thank you for the tough question. I only get to choose one. My experience at Hope with the Science Center has been nothing short of inspiring and magical. It's completely changed my career path. But if I would have to talk about one thing that has truly deepened my passion for science and for research in particular, it would be a couple months back, I was digging back into the literature. I had taken a little break from research, and I was like, I need to get caught up. And had discovered through the scientific community at different labs research that the E3 ubiquitin ligase, or the specific enzyme that attaches ubiquitin to the molecule the protein that we study, XCT, is NED4. And I had all this data from the past 3 years that wasn't quite fitting together. We couldn't quite get our system to model the proper way that we wanted to, because the enzyme is always the key to any reaction. So if we don't have the key, we can only kind of mix our ingredients together and hope that we can try and measure what we're going to. And just having that key and combining both present research and past research into hopefully now an elegant biochemical pathway is just nothing short of magical to be doing at an undergraduate level. So that would definitely be what I think has given me the most excitement, has been the most rewarding. I think as Dr. Sear said this morning, the toughest research challenges that you face are often the most rewarding, and that has been that moment for me.
Jay, how has the building supported hands-on biology, research, and learning? And do you have a favorite experience from the lab or the field that you'd like to share?
Yeah. So we study birds. Well, we don't study birds. We study hearing and use birds as a model. And the building's great. We have an aviary on site, and we can do all of our testing here, which is great. And so that has been really lovely to. As I've visited graduate programs and they have to go off-site for aviaries, I'm more appreciative of our aviary that's down the hall from us. So thanks, Paul. Something from the field or from my lab in particular that's meaningful to me is I actually had the most magical graduate school undergrad moment that you hear about in passing. Our lab travels quite frequently, and I've been given the opportunity to present my work a number of times out of state. And this past January, we were in Georgia, actually at a national conference. It's my first national talk ever, and I was terrified, and it was awesome. And one of Kelly's postdoc friends from IU came up to her and was like, "Do you have anybody who's looking for PhD programs?" And I just spawned. And she came to my talk and took me to lunch, and I started my PhD with her in the fall. So just textbook networking, which I don't think I would have gotten at a bigger institution, and so I'm very grateful for the program for that.
Okay, Lexus. How has the center, the Schaap Science Center, helped you connect biology and psychology in your work?
Yeah, that's a really good question. So I've been able to connect biology and psychology through both my coursework and my research. So further my coursework, I had behavior disorders, which looks at various psychiatric disorders and be able to understand the actual biological mechanisms behind it. But in my research, my senior neuroscience capstone, Dr. Chase, we worked on bipolar rats, able to induce chemically a bipolar disorder. And we were able to do various behavioral assays and look at the connection, correlation between the psychiatric features and the biological underpinnings. As well as in my current research for Dr. Calvo, we study zebrafish to resemble Parkinson's disease for their olfactory system. But we were able to extend these behavioral assays with various anxiety-like behaviors as well as depressive-like behaviors if we so choose to.
All right, Matthias, I have a question for you. How have the labs or classrooms here supported your understanding of human behavior?
Yeah, I think a lot about the different classes that I've been taking over the past years. And something that I typically see a lot of professors always want in their classes is engagement. And I think the sort of structure that we see in these different classrooms, like the smallish places, or just having people face each other in some of the classrooms that are seen here around, or these round table places that facilitate discussion and make everyone feel seen, right? It keeps everyone engaged, make sure that everyone is actively participating. You really have one or two people always answering every question professor asks. So it keeps everyone fun, engaged, and active, and I feel like that's something that really highlights this sort of aspect of human behavior.
All right, Ethan, how have your research experiences in Schaap Science Center prepared you for a life after Hope?
So that's a good question. Last summer I did research with Dr. Alinsky over there. We did tribology research, and this was a very new experience for me. And before coming to Hope, I wasn't really sure if research was what I wanted to do. And so the whole idea of like spending a whole summer doing research was kind of daunting, but that summer was very enlightening for me in kind of discovering that I really wanted to do research. I enjoyed like the whole unknown, kind of like what Sophia was talking about, like the literature is there for us and we're kind of trying to find those gaps. We're trying to understand something new. And so I loved spending a whole summer with her in my lab group, learning about these different things and performing a lot of different experiments. And honestly, from spending time in her lab, it's kind of been really helpful for me in making the decision that after I graduate, I want to continue on to do a PhD and continue with research, because I've loved the experience in her lab and with a lot of other professors. Even in like the learning labs that we do throughout the school year, for example, I did neurochemistry lab. We were engaged with research in that lab. We were looking at system XE-, and it was also an incredible experience to be able to handle and do techniques that a lot of undergraduate students at other institutions aren't able to do just because of like size and maybe financial constraints. And so the fact that we were given an opportunity to do that in that research lab was so incredible for me, and also another reason why the experiences here have helped me like formulate the idea that I want to do a PhD when I graduate.
Miracle, how does collaboration between science and healthcare, what does that look like for you in this building?
That's a really good question. So, just starting off, like I've always had a love for science, and like kind of like where I grew up, I didn't have the opportunity to like have the resources that we have here at the Science Center. Like science has always just been like in a textbook for me. So I feel like walking into this building for the first time as a freshman, like it felt like all those dreams were like true. Like it's like I could see it. And like for the first time in my life, like I looked through a microscope and I was like looking at things that could practically change somebody's life. I got to be in classrooms where I learned a lot about how different diseases affect the human body and like what can be done to help. So just sort of like that experience alone was really life-changing, and I feel like this building gave me the resources and basically the opportunity to. And also being here with the professors as well, Dr. Miles over there. It's just a constant reminder that you're not alone. And I don't know, bringing like science and healthcare, to answer your question, is like it doesn't have to be something necessarily that is separate, because being in the nursing career, it's like compassion is one of the cores, but you necessarily don't have to see science and healthcare as something separate. Like science is literally what fuels healthcare, if you look at it like that. So, yeah, I don't know if that answers your question, but yeah.
Great. All right, thank you so much. So I have a couple questions I'd like to ask, just sort of broad, okay? And I'll hand it to whoever wants to take it. So if you met a high school senior who said to you, I'm thinking of going into science, but I'm not sure I should come to Hope College, what would you say to that student? Sophia?
I'm sorry, I had this conundrum, so I felt called to answer this one. So I'm from high school in Illinois, and not a lot of people go to places that are either on the East Coast or they go to a big state school. Similar to you, Dr. Schaap, I was given some advice from a mentor and friend to come to Hope, and I trusted in that, and it's probably the best decision of my life. So to that senior, I would say, it's hard now to realize that the best thing that you can do to find your passion is to have people who are going to invest and believe in you and who are going to care about you. And I think something that is so incredible about Hope is not only do you have the resources, but you have the people who care. In my first day at Hope College, Dr. Picard sat me down and we went through my schedule, we went through my 4-year plan, and he was like, oh, you gotta take more classes, Sophia, what are you doing? And I think just to have that be your first experience with an institution, right from the get-go, you don't know what you want your career to be, you don't know if you want to do medicine or science or something in between, but you have the people who are invested in you before they even know you, and before you've even given them any iota of a reason to be invested in you. And I think that is just such an absolutely unique thing that only I've ever seen here. And I think it's such a springboard for students to go to other institutions, whether it's a different SURP program over the summer, or going to their first graduate school interview, or actually to that program, to say, I saw this in my lab. Let's see how you do it over here. How can I take the mannerisms, the communication, the experience and the resources that I got to see as an undergraduate and do as an undergraduate, and not that it's just pouring agar plates, but just pouring agar plates, right? You're doing the science and you take that to another institution, and that is a gift that I think when you're a high schooler you don't realize is there. So that would be my answer.
Would anybody else like to take Matthias?
Yeah, something that I really noticed from being here at Hope is this aspect of community and connection. So when I first came here, I heard all this stuff of like the Hope connection, and I was like, that sounds weird. There's no way that this small school in the middle of nowhere actually has that many like people that you can know and get. But I realized just by going to different states and meeting people in the most random of places, they're like, oh, so wait, you go to that like Dutch place, very Christian, in like Holland, Michigan, next to Grand Rapids? I was like, yeah. Oh yeah, I have like brothers, I have siblings that all went there. I was like, oh, that's good to know. And I mean, last year I had a very wonderful experience. I was doing some fundraising for Hope, and I got to meet people from the University of Michigan, and they were like talking to me and saying like, oh yeah, because I was mentioning my research and the work I was doing at the time, and I got the opportunity to work there during the summer. And that was just something that happened because really of Hope. I think there's this big aspect of connection or community where you're able to get experiences that you wouldn't really have in other locations. And also this aspect of getting to know professors so well and building these relationships, it really establishes your career and like just academic field, even outside of the sciences, very firmly. Right? It creates these paths that you really wouldn't have thought about until they actually happen. And I mean, a lot of the stories were highlighted with Dr. Schaap here, talking about where he went and how he got there because of Hope. Yeah.
I'm getting inspired just listening. Does anyone else want to come? Yeah.
Okay, I work for admissions, so I get this question, I worked for admissions. I'm not used to being an alumnus. But I get this question all the time, and students are like, oh, I'm between Hope and U of M, Hope and U of M, and I'm like, yeah, the classic. And I think that what people don't understand, actually, hey, Dr. Alinsky, I had a student who was having this exact conundrum in the last week of classes, and we went and sat in Dr. Alinsky's a discussion for, what was it, PChem? Analytical, sure. And we sat there, and the student was like, this is just a thing that happens, like nobody's alarmed that there's just a high schooler sitting in with two admissions girls, like just hanging out, like, I don't even know what's going on, I'm just experiencing culture right now. And I was like, yeah, this is just life, like it just happens. And I think that that's something that we have that other institutions don't have, is that the science doesn't really change. Like, we've talked literature, we've talked all the things, and literature doesn't change. You have access to the same databases and that kind of thing, but Hope has people, like the people of Hope, we talk about it all the time, and it's just, this building is home, and so within home you have family, and so it's a cool place to be. People are weird, you're listening, like this has been the weirdest kind of like anniversary shindig ever, like the lights are on and off, like things are happening, like it's weird, and this is so normal at Hope, and it's like, it's so beautiful, like it's so beautiful for anybody who's at graduation and heard any of the speakers, like that's just so Hope College. And I think at other institutions and in the sciences, it's not family, it's competitive, and I felt that at graduate school interviews, and it's so nice. Like our lab my work spans over chemistry and biology, and working with an analytical chemist who works at Wesleyan now. But it's so wonderful to just like have family here and have deep roots and be sad to leave and excited to come back, and that's something that's unique kind of to this space. And so, yeah, you've built a massive home with a glass ceiling. And it's beautiful.
All right, well, thank you, and thank you, and thank you, Paul. This is a story that keeps going on. New chapters, and it's getting better and better, and we thank you for all of the investment, financial and human, that goes into this story.